Welcome to this explainer. Today, we're diving into a genuinely powerful blueprint designed specifically for cloud architects, IT operations professionals, and DBAs. We're going to look at exactly how to automate complex database backup metadata collection right inside Oracle Cloud Infrastructure, or OCI. If you've ever struggled with keeping track of highly dynamic cloud environments, you are going to find this incredibly useful. Here's our roadmap. We'll start with the metadata challenge, look at multi-tier architecture, decode those JSON path variables, walk through the actual step-by-step implementation, touch on scaling best practices, and wrap up with unified observability. Let's get right to it. Section 1. The Metadata Challenge, moving beyond basic metrics. So there's a massive difference between basic time series data and deep database metadata. You probably already have those basic metrics from the OCI monitoring service, things like backup duration, size, and recovery status. And hey, that's great, but it's just not the whole picture. To really eliminate those risky blind spots in your infrastructure, you need the deep metadata pulling straight from the OCI database service REST APIs. We're talking about configuration details, specific backup policies, and precise lifecycle operational statuses. To grab that deep metadata, we use what's called multi-tier REST API collection. Basically, this is a sophisticated approach where you first fetch a list of parent resources, extract their identifiers, and then use those IDs to dynamically collect detailed information for each child resource. Think of it like walking into a massive office building, asking the receptionist for the directory, getting the room numbers, and then visiting each specific office to grab the reports you need. Except here, we automate the entire thing. Moving on to Section 2, designing multi-tier architecture, focusing on parent and child endpoints. This beautifully simple three-step workflow takes a complex manual API traversal and turns it into total automation. First up, Step 1. You call a parent list endpoint to return a list of DB homes. Step 2. You extract the resource identifiers right from that exact response. And Step 3. You define child endpoints that use those specific IDs to fetch highly detailed info for each database. The real game changer here is that this architecture frees you from the incredibly tedious, and let's be real, error-prone task of manually maintaining lists of database IDs in your monitoring tools. Instead of constantly updating a hard-coded list every single time a database is spun up or spun down, the system just dynamically discovers and monitors all of them for you. It's an absolutely crucial, scalable solution for modern cloud operations. All right, Section 3. Decoding JSON path variables, which acts as the integration glue. The fundamental mechanism making this all happen is the JSON path variable. These variables essentially take the data from the parent endpoint response and pass it directly into the child endpoint URLs. It acts as this intelligent glue, seamlessly feeding the outputs of your first API call right into the inputs of all the subsequent ones without any manual intervention whatsoever. Let's actually look at how this expression logic works in practice. Say your goal is to extract all IDs from an array. Well, your expression is $.ID. The $sign represents the root. The asterisk matches all the elements, and ID pulls that specific field. If you're dealing with nested arrays, you'd use items bracket asterisk bracket .id. And for the full dynamic usage, we just wrap the parent endpoint name, like listDB homes, in curly brackets, drop in a colon, and then our expression. That exact syntax is what spins up those dynamic requests. Okay, Section 4, step-by-step implementation. Let's actually build this integration. This streamlined UI process makes the setup surprisingly straightforward. Step 1, you'll import the required OCI database info log source configuration directly from GitHub into Log Analytics. Next, you configure that parent list endpoint we just talked about using your JSON path variables. Then, you link it all together by adding an entity association to your management agent host. And finally, you jump into the Log Explorer, run a quick query, and verify that your data is actually flowing. Now, while you're navigating these steps, there is a massive potential pitfall you absolutely must avoid. You have to update the log list URL to include the specific compartment ID that matches your exact OCI environment. If you skip this and just copy-paste the default templates without localizing your API calls by targeting your specific compartment ID, well, your endpoints are going to look in the completely wrong place and your collection will just flat out fail. So don't miss that. Next up, let's check out the request settings. You'll need to show request headers in the configuration, setting the name to accept and the value to application/JSON. But take a look at that third point. By setting log credentials type to none, we securely leverage resource principal authentication. Essentially, This means the management agent automatically authenticates for OCI APIs. You don't have to manage, rotate, or risk exposing any manual API keys. Honestly, it's a huge security win. Moving right along to Section 5, best practices for scaling so you can operate safely. Following these best practices is going to save you some massive debugging headaches down the line. First off, definitely test your JSON path expressions using an online evaluator tool before deploying them. Trust me, it's way easier to catch a syntax error there than hunting through production logs. Second, protect your API rate limits. If you're dealing with a huge number of resources, use compartment-level filtering to optimize performance. Third, strictly apply the principle of least privilege in your IAM policies. Make sure your agents only have permission to read the database resources they actually need. And lastly, always validate your data in Log Explorer just to assure you aren't missing any records. And finally, Section 6, achieving unified observability. Let's look at the final results. By combining this deep hierarchical metadata with your standard time series metrics, you achieve true cross-telemetry correlation. You can finally correlate your database backup metadata with operational metrics from OCI monitoring and the OCI events service. This completely transforms Oracle Log Analytics into a central intelligence hub for your database operations. Ultimately, it allows your teams to make highly informed, data-driven decisions when it comes to backup management, compliance reporting, and long-term capacity planning. It's really the whole shebang. So now that you have the complete architectural blueprint to automate this deep multi-tier visibility, the only real question left is when you'll implement this approach in your own OCI infrastructure. Are you ready to stop hard-coding and start dynamically discovering your database health? I really hope this explainer has given you the clear, professional overview and the structural roadmap you need to make it happen. Thanks for learning with us today, and happy building.